temperature change is proportional to the difference between the object's temperature and the temp of the surrounding medium. What the heck does that mean? It means the colder the room, the faster it'll cool down, essentially, which is kind of makes sense, right? If I have a 100-degree object and I put it into a room of 90 degrees, it's going to cool down slowly. If I take a 100-degree object and put it into a room of minus 30 degrees, it'll cool down faster. That's what it says. That's what it means. So mathematically, we would write that the rate of temperature change. So I'm going to use y because apparently you guys don't like the capital T's. So we're going to write it as y primed. The rate is proportional to, so is, when you say the word proportional, you have a proportional constant, which they use k, to the difference between the object's temperature, which we're calling y, and the room temperature. So the object's temperature is y, and the room temperature. So this is the room temp, and this is the object's temp. All right? So we just translated this statement into a mathematical statement. All right? The rate is always derivative. Is equal, proportional, means you have some sort of constant. The difference, so the subtraction between the object's temperature and the room temperature. Okay? We have to solve that differential equation. So, let's go down here. We'll come back to this actual question, but this is part of it. So we're going to go y primed is equal to k y minus, okay, and we can fill this in actually. We can fill in the room temperature. So actually, we'll just do that right now. The room temperature that we're going to use is 60 degrees. So I'm going to say y minus 60. Okay? All right. Can you solve that differential equation? So first thing, rewrite y primed as what? dy what? dt. It's a rate. It's a rate problem. Okay. What do you do now? Yeah. Get all the dt's to one side, get all the y's to the other side. So we're going to get dy over y minus 60 is equal to k dt. And then integrate. Boom, boom. The one on the right becomes this one. Kt plus some constant c. The one on the left becomes what? You can do u sub. You can say u is equal to y minus 60. So du is equal to dy. So that integral becomes 1 over u du. What's the integral of 1 over u du? ln of u. So we get the natural log of u is equal to kt plus c. And u was y minus 60. Does everybody follow that? Okay. How do I solve for y? Yeah, so we're going to change to exponential form. This is like that question I wrote up with the t's and stuff. That's actually the one I had on the board is actually the same type of question. So you get this. What does e to the c become? Constant. So I get y minus 60 is equal to c e to the kt, therefore y is equal to c e to the kt plus 60. Where did I lose you? Well, because remember, this is like, I could rewrite the natural log if I wanted to as log base e. And then if you're going to change to exponential, that moves up and this becomes the exponent. Okay. Okay, so we have this. Do we have any other information? So this is our sort of general solution, but we've got an unknown of c, an unknown of k. We have to figure those out. So if we go back to the question, the room temperature is 60 degrees, which we already put in. The object cools from 100 degrees to 90 degrees in 10 minutes. How long does it take to reach 80 degrees Celsius? So at T0, what's the temperature? 100. It's initial, what your initial is, right? And at T is equal to 10 minutes, it is 90, right? Right? Because in the question, I tell you it cools from 100 degrees to 90 degrees in 10 minutes. So T0, the initial temperature, like when you take it out, times 0, it's at 100 degrees. 10 minutes later, it's 90 degrees. Okay? So which one do we put in first? 0. So we go back here. When T is 0, Y is 100. So 100 is equal to C e to the k times 0 plus 60. Anything to the 0 is? So we got 100 is equal to C plus 60. So what's C? So C is equal to 40. So now our equation is y is equal to 40 e to the kt plus 60. All right, this is t equals 0, y equals 100. Okay. So now I still have one unknown in there. What is it? K. We got to figure out K. How do I figure out K? Use that, right? T is equal to 10. Y is equal to 90. So we go down. I guess I don't need to put the degrees. But now what? What am I going to do here? 90 minus 60, which is? Divide up to 40. What's 30 divided by 40? 3/4 or 0.75. Same thing. We're going to get decimals here in a sec anyway. So I get that. Then what do I do to solve for K? Change the natural log, or natural log both sides, or whatever you want to call it. You're going to get the natural log of 0.75 is equal to K times 10. So K is equal to approximately negative 0.02877. It's a Vina answer. So that's our K value. Yes? All right, so now we have the actual equation that'll tell us the temperature. So now we have y is equal to 40 e to the kt, but we know what k is. It's negative 0.02877 t plus 60. So this, because this is the thing that's telling us how fast it's cooling, the k value, right? So yeah, it's gross. But if then I say, I forgot what the original question was. How long does it take to reach 80 degrees? Okay. So that means our y is 80. So y is equal to 80. T is equal to how much? That's what we're trying to figure out. Plus 60. And then because you're all awesome at math, you know how to solve this, right? Just silence. Move the 60 over. Divide out the 40, so you get a half. And then natural log. And then you divide them, and you're going to get t is equal to approximately 24.1 minutes. 0.1 of a minute, what's that, 6 seconds? Or 24 minutes, 6 seconds if you want the actual answer. Guess what? You just finished Calculus 12. You have to do 2 questions though. Page 414, 65, and 67. All right, Calc 12 is fini. Your test is on Monday. Your final is like a week and a bit after that. Tomorrow we'll start review. I posted reviews in the classroom, and I'll give you a review tomorrow. Okay?